Hello students. In this problem we're going to construct a partial fraction decomposition of this rational function here. So first thing we're going to do is to factor the denominator into its linear factors. After we do that, we realize, or hopefully we will realize, that when we have distinct linear factors, the partial fraction decomposition will take the following. We have a constant a over one of the linear factors plus a constant b over the other linear factor. Now the trick to solving these problems is determining the constant a and the constant b, of course. Do not be disturbed by the fact that we have a x plus 11, we have a variable in the numerator. It's not relevant to these factors directly, okay? As far as the decomposition goes. Alright, so what I'm going to do is I'm going to clean this up a little bit and just rewrite it up here. Okay, so what we now have is this rational expression has distinct linear factors in the denominator, so we break it into its sum like this. One here on the right hand side. Now there are several ways to solve partial fraction or construct partial fraction decompositions. I'm going to show you one way. What I like to do is I like to take the expression and clear out all the fractions. So what I'm doing here is I'm taking an x minus 4 and an x plus 2, and then I'm just multiplying everything by that denominator. Okay, so then what happens is the denominator on the left hand side clears out, the x minus 4 clears out here, and the x plus 2 clears out next to the b, and we end up with this expression here. Now once you get there, you could turn this into a system of equations if you like. I actually have what I think is a simpler way to solve the problem. What I'm going to do is I'm going to pick a value for x that'll make this term vanish, and it'll just be a constant times this term, and it'll be equal to a constant on the left hand side. So I just will have to solve an equation for b. Now an obvious choice, I think, is if we let x equal minus 2, then this term will vanish because you'll have a times 0, you'll have a 0 here, and if we let x be minus 2, we'll have a minus 6 here, and we'll have a 9 on this side, and then it's easy to solve for b. Similarly, what I'm going to do is if I let x be 4, then this term will vanish. I'll have a 6a here, and I'll have a 17. A 15 on the left-hand side. So let's go ahead and execute that strategy. See, it's fairly easy. So here are the cases again. When I let x be minus 2, then I put in a minus 2 into the left-hand side, so I have minus 2 plus 11 equals, now this term here, the a times x plus 2, will vanish because we'll get a 0 there, and then I put in minus 2 for x here, and I'll get a minus 6 along here. So this becomes a negative 6, that just becomes 0, and this term here simply becomes a 9. So we're going to solve for b, and easy enough, b will equal minus 9/6, or that reduces to minus 3/2. Similarly, if we let x equal 4, then we plug in a 4 on this side, the left hand side, and we get a 15. Here 4 plus 2 is in fact 6, and then this term vanishes, and here we'll solve for a. So a will be 15 over 6, and we get here, and that simplifies to 5 over 2. So now that we solve for a and b, let's go back to our original partial fraction decomposition up here, and so a was 5/2, b was minus 3/2, and that is the partial fraction decomposition for x plus 11 over x minus 4 times x plus 2. All right, good luck.